Hi there and welcome to Pluralsight. My name is Tim Werner, and this course is entitled Software Troubleshooting for CompTIA A+ 22902. This happens to be the first module in the course, which is titled Troubleshooting PC OS Problems. We have a learning path, as I'm sure you know by now, that covers every single content domain and every single objective from the CompTIA A+ 22902 blueprint. The first course is a brief introduction, and then we get into Windows operating systems, other operating systems, security. What we're starting now is the software troubleshooting course, and then operational procedures. This is a shorter course because, frankly, in the objectives, in the CompTIA objectives that you can download from comptia.org, by the way, alternatively check out the exercise files. I'll show you exactly where those are in just a minute. But the four courses are, number one, what we're doing today, troubleshooting the PC. In the next one, we'll stay with the PC but look at security issues. Now, when I say PC here, I'm just taking the verbiage directly from CompTIA, and you're going to learn pretty soon that we're concentrating exclusively on Microsoft Windows. Yes, I know, you may say, Tim, I thought CompTIA was vendor neutral. Well, officially they are. I don't know because I don't know under the hood or behind the curtain how CompTIA specifically develops their objectives, but I know that they do try to keep very current with what's happening in industry, so I suspect they've looked at the predominant market share of Microsoft Windows, the operating system, and that's why Windows factors in so heavily in these objectives. So anyway, we do a module on security, and then for the second half of the course, it's mobile operating systems. We look at mobile OS app troubleshooting and then security troubleshooting. Now, I always like to start my courses with a screenshot of the Pluralsight web player so you know your bearings. You're probably over at the Table of Contents tab where you're watching the movies, but if you take a look over to the Exercise Files tab, this is where you can click to download the exercise files, which in my case, what I do with my courses, it's very simple. I just give you a text file for each module that contains a list of internet links that supplement the training in each module. So if I point you to a website in a module, you don't necessarily need to worry about jotting it down right then. You can just look in the exercise files and get it. There's another tab called Discussion, and this is important because it's where you can ask me questions. I monitor the discussion forums for all of my Pluralsight courses. I actually receive an email notification when someone posts an item of discussion. So get in there, create your free Livefire account, and let's get to learning together, shall we? The overview for these troubleshooting modules is almost identical. You're going to see as we go through, there's a lot of repetition and presentation. Basically, CompTIA gives us a big old list of common symptoms, and we need to develop resolutions for each of those troubleshooting symptoms. And we'll also consider troubleshooting tools. Not on this slide, but what we're going to start with anyway is a very brief introduction to the CompTIA 6-step troubleshooting model, because that really is going to be something we need to keep in mind as we proceed through the rest of all these specific problems and solutions. Meanwhile, in the real world, now if you're coming to this module without having seen any of my other learning path for the A+, then this is probably causing you a little bit of confusion. What does this mean? What I like to do is relay the content as much as possible beyond just the exam objectives and helping you pass the exam, but also how you would see this data in the real world as a working A+ certified repair tech. In this specific example, the customer is asking us, the technician, my hard drive does nothing. It appears that my computer is totally dead. I see that the power button goes on when I press it, but then absolutely nothing happens on my screen, on my monitor. I don't hear that sound of the hard disk moving like gerbils exercising on an exercise wheel. Is the drive dead? Did I lose all my data? And what we'll do is, at the end of the module, we'll come back and we'll answer this fictional customer. Our specific CompTIA A+ 22902 objective here is 4.1, which states, given a scenario, troubleshoot PC operating system problems with the appropriate tools. As promised, I wanted to spend just a couple minutes reviewing the CompTIA troubleshooting model. In looking at the 22901 and 902 objectives, it looks like CompTIA is not stressing this model as much as they have in other certifications, as well as previous iterations of the A+. But anyway, I thought it very apropos to include because most CompTIA certified folks that I know in the industry use either this model or one that it's based on or derived from. Specifically, I want to draw your attention to my 22901 learning path. If you haven't already gone through the troubleshooting course there, I spend an entire module covering the CompTIA troubleshooting model. And by the way, if you don't know what this is, CompTIA, through some kind of behind-the-scenes research that, again, we in the public space have no insight into, CompTIA has developed the 6-step general model for approaching IT troubleshooting issues. And you'll find, if you dive into some research, that different hardware manufacturers like Microsoft and Apple, and software manufacturers for that matter, have their own published troubleshooting models that they promote. It seems that CompTIA has taken an amalgamation, a little bit from Apple, a little bit from Microsoft, a little bit from Cisco. It's really a good model and it's worthwhile. That's why I want to show it to you now. 6-step model. What do we have here? We are a PC repair technician and we're being faced with some sort of software-related problem. I know that the clip art shows a screwdriver. Just look at it metaphorically. Okay, so step 1 is to identify the problem. You're thinking, Tim, that's a little bit Captain Obvious. I think most of us would know that, right? Well, not necessarily. Identifying the problem is going to involve gathering data from the customer. So you need to develop what are called your soft skills, your business skills, your ability to ask open-ended questions. Questions that begin with what, where, when, why, and how are almost impossible to answer with just yes or no. You see, you want to gather as much information as possible so you get a good idea of where the problem might be. If the user, for instance, has a desktop that's covered with pop-up advertisements, then you'll probably want to ask them questions like, who has been surfing the web on your computer lately? What kind of sites have you been going to? And that can get embarrassing for some customers. We'll talk more about that later, but we're going through an information gathering stage. And step 2, we're establishing a theory of probable cause, questioning the obvious. The classic example I give of this in hardware troubleshooting is a user says, I can't get on the network on my computer. I know I'm typing my password correctly, but I just can't access anything. You look down and you see that their Ethernet cable is unplugged. That's an OSI layer 1 problem. Question the obvious, right? If a user's desktop is covered with pop-up advertisements, they must have, or in likelihood, they have gone to the wrong website, experienced a drive-by malware attack where it triggered a whole bunch of advertisements on their screen, and when you click one, another one pops up. JavaScript is a pretty nasty client-side programming language when you use it for that kind of malware. But question the obvious means we don't want to always jump to the most complex possibility. If you've ever heard of Occam's razor, it means try quick fixes because chances are the most likely reason why a problem is happening is in fact the reason why it's happening. Step 3 is where we test the theory to determine a cause. We reproduce the problem. We follow the steps that the user has been doing and seeing if we can reliably reproduce the problem. You may be in the middle of it and there's nothing you can do. It's just obvious that the problem is happening. You've interviewed the customer. You've asked questions like when was the last time the computer behaved normally and what changed between then and now. It's now time for you to establish a plan of action and resolve the problem. Here you want to be careful to make only one configuration change at a time before testing whether that fixed the problem. We don't just want to treat symptoms here. We want to get to the root cause of whatever it is that's causing that problem. If it's a piece of malware, the goal, of course, is to identify and delete that malware as well as restore the user's environment as close as we possibly can to how it was prior to infection. The reason why we don't want to do a whole bunch of changes at once is that it screws up our documentation, which you'll see in step 6. Step 5 is where we verify full system functionality, and here we ask the user to do whatever they normally do with their computer, and we observe them doing it to make sure that the problem has in fact been solved, and then we do our documentation. Now, if you're working for yourself, documentation, you have a very big incentive to do good documentation so you can bill the customer appropriately and have a good record of that transaction. If by contrast you're a support technician within a business, documentation will help you and your colleagues next time around if another user has the same or a similar problem. So as you see, this troubleshooting model does indeed make a lot of sense in the context of IT software troubleshooting. Let's proceed. We're going to look at, like I said, this litany of problems, and we're going to go through possible causes and resolutions of each problem. First, we have a proprietary crash screen, what's called the blue screen of death in Windows. It used to look really scary back in the earlier Windows versions. Now in recent Windows Server, like Windows Server 2012 or Windows 8.1 or Windows 10, the stop screen is much more user-friendly with an emoticon face and everything. On Apple computers, you see the spinning beach ball of death, also called the pinwheel, where the mouse pointer turns into that. And actually, a crash screen in the Mac isn't so much the pinwheel, it's an actual honest-to-goodness crash screen that tells you you have to restart the computer if Apple can't do it or if the OS can't do it itself. Normally, now I say normally because there can always be exceptions to these, is that a hardware conflict, maybe a new piece of hardware, you've installed additional RAM, that's a very common cause of a BSOD and it's incorrect RAM. From a software perspective, something that's going to cause a crash could be poorly written software maybe, or it could be a malware infection. What I want you to do here is note the error codes when you see the crash screen and then perform research on another computer that's not suspect or not infected to do your research and work through the rest of the troubleshooting model. Now, if a computer doesn't boot, it really depends upon where it doesn't boot. If it doesn't boot right at the beginning, then you'll want to go into your CMOS UEFI setup and make sure that the boot order is correct. And you might want to make sure that in your BIOS CMOS UEFI that it's detected the hard drives. If the hard drive's no longer being detected, that may be a hardware problem and not a software problem that you'll need to open the chassis and resolve that way. But software-wise, it's a boot order thing, probably. Now, improper shutdown, Windows will notify you the next time you boot if the machine was not restarted or shut down cleanly the previous time. In that case, there might be a service or program that's interrupting shutdown, getting in the way. So you issue a shutdown command, you come back the next morning, the machine's not shut down. There must be, or there might be, I should say, a program preventing that process from happening. What you can do is just make sure to disable the service that hangs up shutdown, kill the appropriate process so that it can proceed. Let's do 3 more. Spontaneous shutdowns or restarts. The user's working along fine, the system freezes for a second, and then automatically restarts. Users operating just okay, and the machine just spontaneously shuts down. They may or may not, the user may or may not see a BSOD or an OS X kernel panic on Mac computers. Like I said, might be the driver. It could be that the hardware itself is okay, a new video card or audio card, but if there's a bug in the driver, that could cause this repeatable shutdown restart cycle. You want to restart the computer in safe mode. Remember that in Windows, safe mode is a special diagnostic startup where you're installing the absolute bare minimum device drivers. So if it was a device driver that caused the problem, that wouldn't be an issue in safe mode. That's why it's called safe mode. We'd then go into Device Manager and remove the driver, disable it, take additional troubleshooting steps. Speaking of hardware devices, what if it fails to initialize, or if you go into your OS and your new printer or whatnot is not showing up, it appears invisible? Well, assuming you've installed a driver or let Windows auto-load a driver using plug-and-play, the driver itself might be suspect. Again, we're focusing here more, or at least I'm trying to focus on the software side, because the 22901 objectives, the A+ 901, is the hardware side of the certification equation, and on 902, it's the software side, you see? So I don't want to repeat a lot of what I said back in the troubleshooting modules for 901. So you want to take a look at the driver. That may require safe mode, but otherwise you can use Device Manager to inspect the drivers and disable, uninstall, reinstall, etc. Missing DLL. A dynamic link library, or DLL, is a file that essentially is a code library for a program. Windows itself has a whole library of DLL files that it uses. Normally they're in the C Windows System32 directory, and it relies upon the functions and code that's in those DLLs to get work done. It's as simple as that. And if you get a message that you're missing a DLL, likely that DLL's been deleted or corrupted by malware, or the end user, heaven forbid. It could be that a known good DLL gets overwritten by another copy through an installed application. Things you can do to work around this: restore the DLL manually. You could do a system restore. We're going to look at Reg Server 32 in the system file checker later when we cover tools, so I'm just going to bookmark that for now and we'll proceed. Here we go with more. Remember that a service is a process, is a mini application, so to speak, that generally runs in the background with no graphical user interface, and normally services can start up or will start up automatically every time the machine boots. Well, if the service fails to start, it may be a service that has a hardware requirement, and if the hardware isn't plugged in, or it came loose, which is a hardware troubleshooting step, of course the service wouldn't start. There also may be a problem with dependencies. In Windows, we can examine the services using Windows PowerShell or the Service Control Manager, and the Service Control Manager allows us to view for any service any services that it relies on. Those would be its dependencies, as well as other services that rely on it. So sometimes these system services specifically have these dependency chains, and if this one service is down, it can actually bring down a whole lot of others. Compatibility errors with applications. This is very common when you're upgrading to a newer version of Windows. The most common resolution to this is just see if there's an updated version of the application, of the device driver, whatever it is, that is compatible. I actually had to do this for a customer just the other day who was running Mac OS X, and her printer driver wouldn't work because she upgraded to the very latest version of OS X. So we made a visit to the Brother website, downloaded the updated driver, and then everything is just fine after that. Another thing you may or may not be aware of is that Windows has had built-in software compatibility tools for a long time, such that you can modify the properties of an application shortcut such that you work, or the operating system will work in an emulation mode of an earlier version. So let's say you upgraded your users to Windows 8.1, but there's a specific line of business app that just won't work under 8.1, and maybe the vendor isn't yet ready to release an updated version. You can set a compatibility mode such that it runs in a simulated, Windows 7 environment, or you could go back to Windows XP. Microsoft, I think, has done a pretty good job in terms of compatibility tools for individual software products as well as for the enterprise. I believe elsewhere in the learning path, it may be in the 22901, we talk about the Application Compatibility Toolkit. That's a good way for a systems administrator to do software compatibility testing en masse or on a larger scale before rolling out an updated OS version. Now, slow system performance is a very vague and general symptom. Normally, in working with end users who aren't technically proficient, this is the kind of complaint you'll get. My system's too slow. So it's up to you as a technician to drill in with your questions to try to figure out exactly what's going on. Now, from a hardware perspective, the system may be overheated. Is that system at a user's home sitting snugly down on a shag carpet and pressed right up against the user's desk so that all the fan ports are blocked? Is the rear fan covered with lint and dust bunnies? That would be pretty easy to fix. From a software perspective, I would look at the RAM situation. Well, I guess the RAM would be hardware, but the paging file, which is also called the swap file, it's a file on the user's hard disk that's used to swap data between the very fast hardware RAM and the much slower paging file. Originally, the paging file was there as a way to trick the computer into thinking it had more installed memory than it actually did. It's weird that we're still using the paging file in 2016, given that physical RAM has come down in price so much, but yeah, it's still used. You can look online if you want. There are people who have done benchmark testing on systems with enormous amounts of RAM, and it seems that no matter how much physical RAM you have, Windows will still swap data to the paging file. Very interesting conundrum. I'll have to ask somebody at Microsoft about that someday. We're continuing on through our symptoms and resolutions. Don't let your eyes cross. I know it can be a little bit much. If your system or the user's system is booting over and over into safe mode, this could either be a recurring boot problem, like I said, could be a service or a driver or an application or even a hardware problem causing a loop. Remember that Windows, if it's not shut down or restarted cleanly, you'll be prompted to go into diagnostic mode out of the box. So what you'll want to do is continue into safe mode and resolve the problem. And while you're there, open up msconfig and make sure that another technician hasn't manually and statically instructed Windows to boot always into safe mode. That's another possibility, actually. Files that fail to open. Well, what could that be? The most common reason, keeping Occam's razor in mind, is that there's no app association. A user was given a file by a colleague, maybe it's a, .foo file. They double left click it, they receive a message, an error message saying Windows doesn't recognize this file. The user's going to file a support ticket there. They're done, right? Their troubleshooting is finished. But what we can do as technicians, well, we can do a couple things. If it's a specific file type, the user may have a legitimate business need to have that application. I don't know offhand what AutoCAD, the drafting application, uses as its file type, but it may be that the user does have a business case to request AutoCAD. You see what I mean? Alternatively, if it's a file type that you know can be handled by an application on the user's system, it's just not being done so, Windows always gives us the ability to change file type associations. We simply look at the properties of the file in question, and we can change the file type very easily and even do so for all future calls on that file type. In other words, make a permanent change. I gotta tell you, instructor to student, IT pro to IT pro, friend to friend, that there are a few items here that CompTIA gives us that have me scratching my head, and missing NTLDR is one of them. NTLDR is an ancient boot file. This went out before Windows Vista. We're talking Windows XP and Windows Server 2003, and those operating systems are truly and officially dead. You should not be using them anymore. So why do we have to worry about troubleshooting missing NTLDR? Now, it's true that if you delete NTLoader from an old system like a Windows XP box, you're not going to boot. It's going to stop the boot process. Also, maybe it's a remnant from an old operating system install. Maybe you had a dual boot going for a while. I mean, there's a few reasons. I just had to think and be creative a little bit because I'm thinking, CompTIA, I thought that you were dealing with contemporary technology here. The good news about old technology is that sometimes the fixes are really simple. Like in the case of NTLDR, we can simply pull the file off of the Windows XP or Windows Server 2003 DVD, reinstate it, and you're good to go. Similarly, again, weird, missing boot.ini. Well, back in the old days in Windows XP, NTLDR was the first file in the boot process. Once the operating system was identified, NTLDR was sort of the orchestra leader for the rest of the Windows boot, at least until you get into the graphical mode. That's another whole discussion we don't need to get into. But anyway, boot.ini is a text file that if you delete it, basically Windows isn't going to know how to boot the operating system. It tells you where the Windows directory is and where you can get to your drivers and services. So, again, thinking of reasons why you might see this in 2016, an artifact from an old OS install, maybe boot.ini got deleted, but you can recreate the file using bootcfg, bootconfig, or you can just create it manually. They're pretty simple to make. Why are we talking about that? Proceeding, missing operating system. This is never a good sign. When a machine boots, it boots past the point where you're recognizing the system disk, so that's a good thing. So you know that your boot order is okay, and you feel that your hard drive hopefully is okay. It's just that we're stalling at loading an operating system boot file. Well, it could be that you've got some boot sector problems. Hopefully not a malware infection, more likely just a simple corruption. So in Windows, you can boot outside the disk. In other words, use a rescue thumb drive or a rescue DVD, or frankly, just get into Windows pre-installation environment and run bootrec. That's a command line tool we've looked at earlier in the learning path, where you can resolve simple boot sector and boot file problems. Missing GUI, or the GUI fails to load. This is interesting. It could be that the system is booted into Windows recovery environment. Now, Windows RE is that light blue screen. I'm going to show you that in some slides coming up if you're not familiar with it, but it's the current way that we boot a computer into a recovery mode. If you go to repair your operating system, you're in RE. And if that's the case, you're not getting the user's desktop, look and see, have you in fact booted off of a Windows RE DVD or thumb drive? If you did, unmount those devices, restart, and see if you can log on. It's as simple as that. Now, if the user's logged in and the GUI disappears, that means that Explorer.exe crashed in all likelihood. Explorer.exe is the main process that governs the GUI environment in Windows. And you know what you can do? You can do a line of PowerShell, start process Explorer, or you could open up Task Manager by doing Control-Alt-Delete and do File Run and just restart the Explorer process and you should get your desktop back. This is the final screen here, so let's rejoice together. Again, from the What Are You Thinking CompTIA files, we have missing Grub or Lilo. Grub and Lilo are boot orchestrators for Linux, okay? They're Linux bootloaders. Why this is coming up in a Windows module, I frankly have no idea, other than maybe you're doing a dual boot between Windows and Linux, and the user's booted into Windows and they see these wacky files on the Linux partition, which frankly they wouldn't see because Linux uses a file system that's not visible from within Windows by default. You see, I'm really trying to stretch here. I'm really trying to stretch. Bottom line is, if you do have a missing Grub or Lilo and you can't boot a Linux system, you'll want to boot off of a live DVD, a rescue DVD, and there are Linux commands that allow you to reinstall the loader. It's actually not a big deal at all. Linux, as you probably know by now, is a much more, shall we say, propeller-heady operating system. It gives you much more control as a systems administrator, right down to the kernel of the OS, than does Windows. Again, a little bit weird, kernel panic, that's an Apple term. If you read the OS X literature, when you get the equivalent of a blue screen of death in OS X, it's called a kernel panic. And once again, the best advice here is to note the diagnostic output. OS X does a pretty good job here because when you force a reboot after having a kernel panic, when you get Finder back, Finder is Apple's equivalent of Explorer.exe, by the way, you'll see a window pop up automatically that asks you if you want to send all this diagnostic fluff to Apple, which is a good idea, I think. But you also want to take a copy of that output for your own reference. Finally, multi-monitor misalignment orientation. So you have a user with multiple monitors and they're all discombobulated. They have warped screen on one screen and half a screen on the other. You want to make sure that the monitor, the video card, and the device driver are all in synchrony. You also want to check the software on the monitor itself. Remember, the monitor likely has its own user interface and its own settings, as well as the driver controls, the software controls. All right, now let's go through a bunch of troubleshooting tools. We'll do this quickly in a lightning round because I want to get to the demo. I'm going to give you 2 per page. These are almost like flashcards, and what's good is that you should know most of these by now. BIOS UEFI. Been there, done that, bought the t-shirt. SFC, we've been here too. This is the Windows System File Checker. You see in the console, I run SFC/scan now to check the integrity of all of our Windows system files. So the idea is if a system file's been stepped on by malware or another application, SFC will restore a fresh copy of those files for you. Log files. These are your best friends. When you're troubleshooting applications and services, research to find out, number 1, if they create log output, and number 2, where you can find those logs, because this is the way that the computer, the application, service, whatever, is communicating with you. The recovery console, again, scratching my head here. Recovery console is an old, archaic term. We're talking, again, Windows XP, Windows Server 2003, where you could boot into a special diagnostic mode, very low tech. I'm actually going to demo that for you in the demonstration. But what we have nowadays is the Windows pre-installation environment, which is much prettier as you see in the screenshot. You have your mouse available. You can easily get your network stack up and running. That stuff isn't possible with Recovery Console. Recovery Console is a dinosaur, but I guess you need to at least recognize it for your A+ test. msconfig, been there, done that, bought the t-shirt. That gives you access to boot order, system services, startup applications, and various tools. Defrag, it's a command line disk defragmenter, and as you can see in the window, you type something like defrag D with /U/V. Those are called switches or parameters. So I'm saying I want to defrag my D drive and I want to see lots and lots of verbose output to see exactly what's going on. regserve32, this is a command line tool that you use to register and unregister DLL files. The only time I've ever used this as an IT pro is exactly the case you see in the screenshot. On Active Directory domain controllers, the schema is so critical to Active Directory that Microsoft actually makes you jump through a hoop before you can manage it. You have to run regserve32 to load the schema management DLL, and then and only then you can start to get into the schema and do whatever work you need to do. Regedit, been there, done that, bought the t-shirt. This is the graphical front end to the registry hives, your user settings and your computer settings. We could look at it as a comprehensive database of the system configuration, and when we use tools like group policy to do configuration, what group policy is really doing is modifying registry keys and values. Event viewer is, again, it's tied in with the logging subsystems. You want to get into the habit of getting comfortable with Event Viewer, the data that's stored in there, make a note of those event IDs and perform Google research, because it's one thing to have a hunch about a problem, it's another to have the operating system or the application actually tell you through information, warning, and error event messages. Safe mode. This is a screenshot from the Windows Server Advanced Boot Options screen, and you'll notice we can repair the computer, we can go into safe mode with or without networking, we can go into safe mode without Explorer, just the command prompt. There's some really good stuff in there. We've covered getting into safe mode a lot previously in the learning path, so let's proceed. There's the old command prompt. Now the command prompt is cmd.exe, and it looks like the PowerShell console, but know that those are in fact separate applications. The command prompt dates back to the earliest days of MS-DOS, and PowerShell console is PowerShell.exe, and that is simply the console host for the PowerShell runtime environment. Emergency repair disks, again, a head scratcher. This is something that goes back even earlier than Windows XP. It's absolutely insane. The current equivalent, I couldn't find a really good current equivalent, so I just gave you a screenshot of the MS Dart tools. You're going to learn more about these in the next module. But what this is it's not a floppy disk like the original ERDs were in Windows NT. You create a Dart USB drive or a DVD, and it allows you to boot off of that media and then perform troubleshooting and diagnostics and recovery from outside the infected or troubled system. Automated system recovery, once again, no longer exists under current version of Windows, but it's the same idea of what we have now with system image backup. I know we covered that earlier in the learning path. Remember that system image backup allows you to take a snapshot of your entire system and put it on another disk, another volume, and then if your system is so hopelessly hosed, or if you just want to renew the system, put it back in time to a known good, known stable state, you can use system image backup. Uninstall, reinstall, repair has gotten a lot easier to do under current versions of Windows. This here shows you the troubleshoot screen in Windows PE, Windows Pre-Installation Environment, in Windows 8.1. Notice that with a single click of the mouse you can initiate a refresh or a reset. Refresh is kind of like repairing the operating system. It allows Windows to renew all of its system files, and you don't lose any of your personal data and settings. Reset is something that you would do if you were selling or giving away your system. That erases everything but reinstalls Windows and keeps everything at OEM factory defaults. Alright, that's it. Let's get into the demo. Alright, Areno, in this demo I'm going to show you some of the legacy software troubleshooting tools built into Windows. I'm doing that because, as we've seen, CompTIA is mentioning not only the current generation stuff, but they're making reference to the old stuff that you shouldn't be using anymore, and I want to make sure that I fully prepare you. So you're looking at the lock screen of a Windows Server 2003 R2 Enterprise Edition machine, and I'm going to send a Control-Alt-Delete in and log on as a local administrator. The first thing I want to show show you is the root of the C drive. If you haven't seen Windows Server 2003, it looks a lot like Windows XP. Now you notice that we don't see anything besides this handful of folders. That's because system files are hidden by default. So let's open up folder options. Now the folder options hasn't changed at all really, all the way now to Windows 8.1. Now I am showing hidden files and folders, but I'm going to unhide protected operating system files. And I also want to get rid of the extension. Let's see here. Hide extension for known file types. That's already unchecked. Good on Microsoft for that. There's NTLDR. There's the paging file, 1.5 gigs. Remember, paging file is your swap file for RAM. There is ntdetect.com, which we don't need to talk about, boot.ini, which is just a simple text file. Let me quickly boost the font here. That allows you to create a bootloader screen to make dual booting multiple operating systems easier, and also gives you these really wacky, what are called arc paths to the location, to the specific disk controller, disk, and partition that the Windows directory is located on. Oh boy, this is bringing back bad memories. I want to show you the recovery console here. So what we're going to do is I'm going to boot the computer off of the Windows Server 2003 DVD. I'll pause the video and resume it once we've gotten there. Okay, and we're back. Believe it or not, this is how installing Windows used to look. This 16-bit character mode, no network, no mouse, no nothing. And the extra Chrome you're seeing at the bottom is not part of the virtual machine. You're seeing some of my VMware workstation. But anyway, instead of setting up Windows, we're going to repair the Windows installation by pressing R. We're going to hit the recovery console. It says the recovery console provides system repair and recovery functionality. Which Windows installation do we want to log on to? I want to log on to the only one that's there. This reminds me of the terminals in Fallout 4. I just started playing Fallout 4 the other day when the game was released. Yes, I'm that kind of fanboy, or should I say Pip-Boy, or Vault-Boy, or whatever. Anyway, type the administrator password, okay? And there we have it. We have access to Windows. Let me CLS to clear the screen and type help. Help gives us a bunch of basic commands that we can use in the recovery console. Note that we have fix boot and fix MBR, list SVC, list services. So it's more commands than you get in the normal cmd.exe shell, but that's really not a whole lot of stuff in there, is it? I'm going to force a reboot, and then actually I'm going to stop the video again. I'm going to pause it. Let me just tell you what I'm going to do. I don't want you to have to see this. I'm going to restart the computer and then start furiously tapping the F8 key. F8 is, well, worked a lot better in old versions of Windows like this, number one, but it's your SOS key. And I want you to see the advanced options screen, and I want you to see what safe mode looks like, because we're going to actually be mentioning safe mode a lot in the next module where we're dealing with security troubleshooting. So hang on. Here we are. This is the Windows advanced option as it appears in Windows XP and Windows Server 2003. Like I said, we have our 3 ways to do safe mode. Safe mode with networking being really nice if you need to temporarily hit the internet, maybe to download antivirus definitions. The system's really hosed with malware. It may not let you, but that's another story. We have a lot of other modes that we can choose from here. Now, because this is a server, we have an option called Directory Services Restore Mode. But what I'm going to do here is hit regular old safe mode. And I just have the one installation, so I'll press Enter to continue. We're getting a lot of verbose output as the configuration's being built. And by configuration, I mean drivers and services. We need to log on. You'll note that we have 640 by 480 resolution. We get an alert telling us we're in safe mode, and now we're here. We can see the build of the operating system. We see these safe mode notifications. We see a black screen. Any custom wallpaper we had is no longer there. But otherwise, whether we're recovering data, copying files off the C drive to an emergency disk, or whatever specific troubleshooting we're doing here, we're fine. And then when we go to restart again, I'll choose restart here, we're going to attempt a normal start unless and until you've overridden that. What's interesting is that the msconfig system configuration utility has been around in many years, and again, it looks almost identical, although, and this is funny to some of you who have been in the game for a long time, we have tabs here for system ini, win ini, and boot ini. Just actually, this gives us a better interface to boot ini than modifying the raw file itself, but system and win ini, that dates back to the very beginning of Windows, like Windows 3.1. From our Meanwhile in the Real World files, remember that our fictional customer said, "My hard drive does nothing. Is the hard drive dead? Is the computer dead?" Well, remember that at the beginning of the module, I gave you some clues by saying that there still is power getting to the motherboard, and it seems like everything else is working. It's just that there's no output on the screen and absolutely no error messages, just a black screen. So my reply would be, let's have a look. What do you have going on backup-wise? Because unfortunately, I've had this happen with a customer a couple weeks ago. Same exact situation, and I suspected strongly that his mechanical hard drive had reached end of life. So my biggest concern was what he had backup-wise. Because remember, we can always reinstall an operating system and applications, and we can always take the time to reset our preferences the way that we want them. But in terms of those documents and photos and media files, those could be very precious, and when lost, are in fact permanently gone. For homework, I want you to fire up your virtual machine. Hopefully it's running Windows 8.1 or Windows 10. And I want you to go through those slides that I showed you and test out each and every one of those tools. Perform research, because really it's like learning any other skill. If you learn woodworking, you become familiar with the tools and get really comfortable with their capability. And you need to do that before you can actually use the tools to build stuff. Similarly, we need to understand our inbox Windows tools before we can leverage them in solving problems. For further learning, check out Veronica Henry's old course from the CompTIA Server Plus learning path. Note that this is an old course. It doesn't map to the current Server Plus objectives, but her course Part 3, Security and Troubleshooting, has an entire module that discusses the CompTIA troubleshooting theory. Also check out my friend and colleague Ross Bergertis' course, Troubleshooting for CompTIA Network Plus. That does cover the latest N10006 Network Plus objectives. Once again, he has an entire module devoted to troubleshooting theory. If you think I'm being a little bit too intense with the focus on having a troubleshooting theory or a troubleshooting framework, I'm really not. I'm just trying to give you some sage wisdom, having been in the industry a long time and having gone through many different phases. My troubleshooting methodology has certainly evolved over the years, and I'm a big believer in these frameworks now. In summary, the focus here has been almost exclusively Windows. There were a couple random objectives that mentioned Linux or OS X, but we're really firmly entrenching ourselves in our Windows Power User Apprenticeship. I hope that that makes you happy. Okay, so that is Module 1 down. The next module in this course, we're going to look at PC security. That's really fun and interesting stuff, but at the same time extraordinarily frightening for the person whose system is infected. So I'm going to roll some soft skills training in there as well as the tech stuff. Thanks a lot for your participation. I'll see you then.